So now let us also discuss in detail regarding the variation of G with respect to depth, and this is a little complicated and let us go through that in detail. Try to listen this carefully, children. Variation of G with depth. So concentrate properly. Variation of G with depth. As usual, we have to consider the earth. Earth is somehow like a spherical, approximately something like a spherical in shape. And let us consider the radius of the earth as something like r. Earlier, the body was taken from the surface of the earth to height h. So everything in and around atmosphere is there. And there is no variation in the density of the atmosphere is being observed. But the same case when the body is taken inside the surface of the earth. We know that earth is a massive substance. Some mass is present inside. As we go deeper into that, only portion of the radius affects. So this will be your radius, new radius r dash. Earlier radius was bigger one. Here, when the body was here, radius we have to consider this. Now, the body was taken inside. When the body was taken inside to a depth d, this depth d, when the body was taken to a depth d inside, the radius decreases to some r dash. Is that clear, children? So, two different radius has been. So, whenever the radius is being decreased, the mass of the earth is also decreased. So, here we observe the variation in mass. Earlier in the atmosphere, when height is taken, no mass density variation is there. So, no mass variation. Complete mass of the earth affects on the body. But here, as and when you go deeper inside the earth, the mass of the earth, only portion of the mass of the earth is affecting that body. So, we have to consider only this portion. The complete portion, complete earth mass, if you consider it as m, the new mass when it is taken inside, only small portion of which it is affecting, and that is taken as your m dash. So, because density varies, larger amount, less, density is constant, but mass is varying. But anyhow, we'll be considering it as a spherical shape, children. So, for this, first of all, look at the formula. What is the relation between density and mass? Density equals to mass by volume, or mass can be taken as, if you bring the volume to the other side, volume into density. Mass is equals to density into volume. Is that part clear? Mass is equals to density into volume. So, always replace mass with density into volume. But volume of what? What is the shape of the earth? We have approximately taken as the shape of the earth as spherical in shape. So, what is the volume of a sphere? Formula is 4 by 3 pi r cube. So, volume of the sphere is taken as 4 by 3 pi r cube. So, here also we will consider two conditions, children. First of all, on the surface of the earth. Case 1, on the surface of the earth. On the surface of the earth means this yellow color you identify. So, the complete mass m is affecting the body. Then acceleration due to gravity on this case, due to this case is G is equals to capital G m by r square, and this is equals to G. Mass can be written as density into volume. Let us consider the density of the body, complete earth, as rho. Density means mass by volume. So, density of a substance always, whether it is inside, outside, upper layer, anything, it depends upon the material with which we have, whatever we have considered. So, density, outer, inner, wherever you consider, density is always constant. Let us indicate that density as rho. So, mass is equals to density, that is density I considered it as rho and volume as some V. So, mass is replaced with the density into volume of that sphere upon r square. Formula for volume of that sphere is equals to, this is G rho, volume of the sphere is 4 by 3 pi How much is the distance from here to here? It is radius r. So r cube whole upon r square. So simplifying this further, r square and 1 goes twice, then you are left with r. How much is that r square upon r? Sorry, r cube upon r square is nothing but r into r by r into r. 2 times gets cancelled and you are left with single r. Therefore, the value of G on the surface of the earth in terms of density, same G equals to Gm by r square only, but I wrote it in terms of density. That only makes the difference. So, G rho 4 by 3 pi r. On the surface of the earth in terms of density, acceleration due to gravity is taken as capital G rho 4 by 3 pi r, and this be equation 1. Similarly, as the body is taken deep inside that earth, from here to here we have carried, amount of mass of the earth decreased, only this portion is affecting, and that new mass I have considered it as m dash. In that case, case 2, at a depth d inside, how much would this be? The value of G is as usual, Gm by r square formula. But here mass also is changing to m dash, radius also changing, radius also decreased r dash, mass also decreased m dash. So this must be equals to, that new gravity G dash is equals to universal gravitational constant m dash upon r dash whole square, r square, Gm by r square. M is replaced with m dash, r is replaced with r dash. That's it. Same formula, copy paste. And for this G keeping constant, formula for mass is density into volume. Density, whether it is inside, outside, on the surface, whatever you consider, density is rho. Volume. So what is the volume of a sphere? 4 by 3 pi r cube. But this portion of the sphere volume, how much is a 4 by 3 r dash cube? How much is that? 4 by 3. The radius changed. So 4 by 3 pi r dash cube whole upon. Mass equals to G as kept it is. Mass is density into volume, rho into volume, rho into volume of the sphere is 4 by 3 pi r cube. The new radius is now taken as r dash. So r dash cube upon r dash square. So following, proceeding as usual, this r dash goes 2 times, then you are left with r dash only. Then the value will be G rho 4 by 3 pi r dash. Is that so, children? So how much is that? G rho 4 by 3 pi r dash. So now let us divide the two equations. So this be equation 2. So now let us divide equation 2 with equation 1 and see what happens. Dividing equation 2 with equation 1. What is equation 2? LHS G dash. Equation 1 LHS is G. Equation 2 RHS is G rho 4 by 3 pi r dash. And this is G rho 4 by 3 pi r. Simplifying further, G gets cancelled, rho gets cancelled, 4 by 3 gets cancelled, pi gets cancelled. Therefore, the value of G dash upon G is found to be, or else I'll write it down. So, G dash is equals to, bringing the G here, G times of r dash by r. R dash by r. So this is the relation. The new acceleration due to gravity when it is carried inside to a depth d is G is equals to r dash upon r. But what is G dash? Let us redefine this. So, children, from here to here, the value was r, and from here to here the value was d. Okay, here to here the value was r, and here to here the value was d. Then what would be the value from here to here? It will be the total r minus d. So this portion is total r minus d. From here to here it was r. as you have went deeper D inside that, the only portion left over is R minus D. That is, how much is that? R minus D. So, this is nothing but the new distance R dash. So, therefore, R dash is equals to R minus D. So, substituting above, we have this implies G dash is equals to G times of R minus D by R. As R is common to both, it can be written as G times of 1 minus D by R. How much is that? The new value of acceleration due to gravity was found to be G times of 1 minus D by R. But earlier example, we have considered that G by GH equals to 1 plus 2 times of H by R. 2 times of H by R, and that is only D by R. So, reduced by D by R times, increased by twice of H by R times, plus there and minus here. So, how much is the effect? Double to this. If the value of G is decreasing here by D by R times, there it is increasing by 2H by R times. So, how much is the effect variation? Double the times of that depth. Okay. So, this is all about the variation of G with respect to the shape, with respect to the height or altitude, and with respect to the depth. So, these formulas you need to remember, children. G dash is equals to, at depth, G times of 1 minus D by R. Height, GH is equal to G times of R by R plus H whole square. With respect to shape of Earth, only that we consider that gravity at equator is lesser as compared to the gravity at poles, and hence weight at equator will be lesser as compared to the weight at poles. Okay. So, this is all about your variation of G. So, one more point, children. Once let us recall back the depth condition. So, what is the value? The new value G dash is found to be G times of 1 minus D by R. Let us suppose that the body is taken deep inside the earth such that it is taken to the center of the earth. It is taken to the center. The same body is carried deep inside the earth. So, how much distance are we moving? So, you are moving this depth going inside, totally the value of D is taken to the center of the earth, that is until the radius of the earth. So, you have covered a distance which is equals to R, depth which is equals to R. So, if you replace the value of D as R, then how much it will be? The value of new acceleration due to gravity at the center of the earth is found to be, so, G dash, this G dash is equals to G times of 1 minus, instead of D we have to replace it with R upon R gets cancelled. So, this is equals to G times of 1 minus 1 minus 1, and 1 minus 1 is 0, G into anything is 0. So, the acceleration due to gravity at the depth deeper inside the earth at the center of the earth is 0. So, that is what? Acceleration due to gravity at the center of the earth is found to be 0. Clear, children? So, this is all about your acceleration, variation of acceleration due to gravity with respect to depth as height as well as others. So, children, before moving to the next concept, let us recall back a few points that we have revised till far. First of all, the value of acceleration due to gravity. It's all about the value of acceleration due to gravity. So, what was the first thing we discussed, children? The value of acceleration due to gravity. The value of acceleration due to gravity depends upon the mass of the earth, acceleration due to gravity on the surface of the earth I am considering. So, it depends upon the mass of the earth as well as the radius of the earth. So, acceleration due to gravity depends upon the mass of the earth as well as the radius of the earth. Why? Because the formula we know that G is equals to Gm by R square. So, the acceleration due to gravity depends upon both the mass as well as radius of the earth. So, this is the first thing you need to know. Next one, the value of g, acceleration due to gravity on the surface of the earth, is found to be 9.8 meter per second square. How much is that, children? The value of acceleration due to gravity on the surface of the earth is found to be 9.8 meter per second square. Next one, as we move away from the surface of the earth, as the value of h increases, the acceleration due to gravity decreases. The value of acceleration due to gravity decreases with respect to the altitude or height by a factor where the value of gh is equals to g times of r by r plus h whole square. It decreases by a factor of g times of r by r plus h whole square. Similarly, the value of acceleration due to gravity also decreases as you go deep inside the surface of the earth. Okay, and decreases by a factor with respect to depth, and it is given as g times of 1 minus d by r. How much is that? G times of 1 minus d by r. So one more point you need to know, children, that is the value of g at the center of the earth. The value of g at the center of the earth is d is replaced with r. So r by r is 1 minus 1 is 0. So at the center of the earth, the value of acceleration due to gravity is found to be 0. Over. So well, next, the value of acceleration due to gravity is found to be minimum. The value of acceleration due to gravity is found to be minimum for Mercury. Minimum for Mercury, whereas the same value is maximum for Jupiter. What makes the difference, children? Mass of the Mercury is very small as compared to the mass of the Jupiter. So larger the mass, larger will be acceleration due to gravity. Lesser the mass, lesser will be acceleration due to gravity. So the acceleration due to gravity at Mercury is observed to be minimum, whereas on the Jupiter it was observed to be maximum. Okay, children. The value of g is the value of acceleration due to gravity. This is any earth, and this is some ball object. It is been falling, and if you consider mass of this object as some m, then the value of acceleration due to gravity is depend upon the shape of the earth, size of the earth, okay, everything, but it is independent of the shape and size of the object that is falling. So here, so the value of g is independent of shape and size of the object. Shape and size of that, not earth, that is object that is falling. So these are the main points you need to know, children. Well, children, the rate of decrease in acceleration due to gravity with respect to height is twice as compared to the rate of decrease in acceleration due to gravity as compared to the depth. Okay. So one more thing. The acceleration due to gravity, the rate of decrease, I'll write it something like this. Rate of decrease in the value of acceleration due to gravity with respect to height is twice of the rate of decrease in acceleration due to gravity with respect to depth. In g with respect to depth. Okay, children. So these are the main things. Also, children, one more thing you need to know. 9th. That is, the value of rotation of earth also affects the value of acceleration due to gravity. rotation of Earth affects the acceleration due to gravity. The value of G. Remember that more faster it rotates, lesser will be acceleration due to gravity. Slower it rotates, larger will be the acceleration due to gravity. Suppose if this acceleration due to gravity, so let us suppose that if the Earth stops rotating, what happens if the Earth stops rotating? The value of acceleration due to gravity increases. Whenever Earth stops rotating, whenever Earth stops rotating, the value of G increases by 0.034 meter per second square. The value of acceleration due to gravity increases by 0.034 meter per second square whenever the Earth stops rotating. So these are the main things you need to know regarding the value of acceleration due to gravity. The variation of acceleration due to gravity with respect to these features. Okay, children. So just go through this carefully, children, and then we'll meet in the next video. Until then, take care. Thank you.